Welcome to the class on chassis and body engineering. This is in continuation to the first lecture that was on aerodynamics of moving body. So, wherein we saw various kinds of the definition of aerodynamics. Then we saw the role of F1 car or the Formula One car, how the aerodynamic design is going to affect that. F1 car racing. Then we also saw the concept of downforce. So all those were part of the first lecture. And moving on to the next part of the lecture, we have. For today's class, let me give you a brief introduction on what could be the prerequisite or recapitulations for the class to move forward. So before coming into the class, the various prerequisites that is required from your end is the meaning of aerodynamics. You should be able to tell the meaning of aerodynamics, which we have already discussed in the previous classes. You should be able to correlate the meaning of friction and what is the role of friction with the aerodynamic study. So what's the role of friction in aerodynamic movement or aerodynamic design of a car so that it propels forward? Some fundamentals of fluid mechanics like the concepts of lift and drag in vehicular design is also important in taking the class forward. Then history of aerodynamics in chronological order, that is in which era what development has taken place over the period of time. So in order to improve the performance of the vehicle, so how aerodynamics has played an important role. So that's going to be the prerequisites for the class. So coming to the main agenda of today's class, that is the objectives of today's class. So I have listed a few in the sense 5 objectives that is expected to be covered as a part of this lecture series. So the first objective that is going to be delivered is you'll be able to understand the meaning of drag force. So as we have discussed in aerodynamics, that drag force is one of the important factor in aerodynamics, and in today's class we will understand its meaning to a very broader aspect and also its scope in vehicle industry. We'll also understand as a part of objective 2, we'll also understand the types of drag or the classification of drag based on what parameters. The third objective for today's class is all about to understand the effect of different types of drag in motion of an object. So whatever the types of drag that we'll study in objective number 2 will be taken deeply so that its effect while the motion of a car can be studied. So that's objective number 3 for you. So objective number 4 will touch on the principles of wind tunnels. We'll understand its basic functionality, and we'll also go through the last objective, which is to classify the wind tunnels based on few approaches. By few approaches, it could be based on design, it could be based on the airflow. So as and when the class moves forward, you'll be able to understand, or you'll also be able to classify the wind tunnels based on different approaches. So moving forward, so the introduction of today's class is all about what is the fundamental meaning of the term drag. So before going on to describing what the drag is all about, let me just brief you about the aerodynamics part of it so that you could correlate what is the fundamental agenda of the drag. So aerodynamics, as I told you in the previous classes, that it is the way the air is going to move around the things. The things may be car or aeroplane or any vehicular body in that sense. So how the air moves around the things, so that defines the aerodynamic study. So it is the study of the the properties of the moving air and the interaction between the air and the solid bodies moving around it. So that is the aerodynamics definition. And then the automotive aerodynamics in the sense that how it's going to affect the aerodynamics of the road vehicles. So in particularly we'll focus on the road vehicles, mainly the car, the Formula One car, etc. So we also aim at reducing what do you call as the drag. Drag has to be reduced. So before going into the drag, the main objective is to reduce the drag and also to minimize the noise emission and preventing the undesirable the lift forces. So the objectives of having an aerodynamic design is that you need to influence the way a car cuts through the air, or the resistance to the movement of air, resistance against the movement of air, so that the car moves or the propels forward. So that's the main point or the main theme why aerodynamics plays a very important role, and to be particular, to be specific, the role of drag. So we need to reduce the drag. So that's the overall objective of the vehicular aerodynamics. In the same context, we also need to reduce the wind noise. We also need to provide the engine cooling, heating, and ventilation. We also need to prevent the undesirable, what do you call, lift forces. There are two terms. One is called as drag, the other one is called as lift. So we need to prevent the undesirable lift forces at very high speeds, which generally a Formula One car runs at, and also to produce a desirable downwards aerodynamic forces to improve the traction. So these were some of the objectives of the vehicular aerodynamics. Now coming to the definition of the drag, as you can see, the drag is a term which is used to denote the resistance to the airflow. So sometimes when you look at the word drag, sometimes it is called as air resistance. In some books you will find it as written in other words, it is air resistance. So it's by air resistance, I mean to say that it's a type of friction. It's a type of friction, or in other words, I can say fluid resistance. Or in other words, if you ask me, it is another type of friction or fluid friction. So that's what is a drag. So example of drag include if you hold your arm out of the window of a moving car. So what happens? You're generally experiencing a drag. So whenever you are pulling your arm out of the window of a moving car, you're experiencing a drag, you're experiencing the air resistance against the movement of your car. So that is nothing but the drag. So in other words, I can also say that it's a force which is acting opposite to the relative motion of any object moving with respect to a surrounding fluid. So I hope this is clear. The definition is very genuine in the sense that it says a drag is a force, a kind of force which is acting opposite to the relative motion of any object. For example, a car moving with respect to a certain surrounding fluid, and the surrounding fluid is nothing but air in our case. Okay. So the drag can exist between the two fluid layers or surfaces, or a fluid and a solid surface. So it can exist anywhere, either between the fluid layers or a surfaces, or a fluid and a solid surface. So unlike we have come across in physics that there are various kinds of resistive forces that exist in motion. So unlike other resistive forces such as you would have come across the term like dry friction. So unlike other resistive forces such as dry friction, which are nearly independent of velocity. So this is one of the important parameter, that other resistive forces such as dry friction, everything is independent of velocity. But remember, drag force is the force which purely depends upon the velocity. So this is one of the important takeaway of today's drag portion, that drag depends upon velocity. So take a note of it. Drag will depend upon velocity, but unlike the other resistive forces like dry friction, which doesn't have any relation with velocity, but drag force has got a very high correlation with the velocity. So drag force is proportional to the velocity for a laminar flow and squared velocity for a turbulent flow. So in fluid mechanics, we would have come across laminar flow and turbulent flow. So in a laminar flow, that is a streamlined flow along a certain well-defined path, the drag force is directly proportional to the velocity of that fluid. But when it comes to turbulent flow means when there is some eddies that is being created in the flow of the fluid, or some turbulence, some disturbance, that is some external disturbance that is created in the flow of the fluid, that is, it is not a well-defined path, it is a zigzag path. So in that path, the drag force is dependent on the squared velocity, that is v square. Drag force is directly proportional to v square for turbulent flow, whereas for laminar flow, it is drag force is directly proportional to v. V means velocity. So next, even though the ultimate cause of a drag is viscous friction, the turbulent drag is independent of viscosity. So viscosity, in the sense the resistance to the movement of the fluid, it is termed as viscosity, and the turbulent drag is independent of that viscosity. The main cause of drag is viscous friction. So drag force, what it does is it will always, decrease the fluid velocity. So whenever the fluid is flowing, it is going to decrease your fluid velocity relative to the solid object in the fluid's path. So in the fluid's path, if there is an object and if the fluid is experiencing a drag force, then ultimately the drag force will, what it will do is it will reduce the fluid's velocity. Fluid's velocity is going to be decreased, which is coming in contact with the solid. Okay, so that's all about the fundamental meaning of drag. Now there are various kinds of drag as well. So before going into various kinds of drag, so before going into the various kinds of drag, so let me brief you with some of the terminologies that we should be thorough before going into the types of drag. So first one, as I told you, it is laminar flow. The second one is turbulent flow. So before going into that, let me tell you something about the what do you call streamline flow. So you should be thorough with the streamline flow. Streamline flow, there's streamlines are used to study the airflow velocity distribution. So streamlines means the well-defined paths, or you can say well-organized paths in which the fluid moves, and the flow with parallel velocity vectors. So flow with parallel velocity vectors are termed as streamline flow. So generally laminar flow can be considered as the streamline flow, since it has got a well-defined path and well-defined velocity vectors, parallel velocity vectors. So that is why it is called as streamline. Next one is turbulent flow. Next important terminology is turbulent flow. In turbulent flow, as I told you, the fluid motion is not well organized. It is not well defined. The path is not well defined. It will have some eddies in the motion. That is, it will have some external disturbance. And fluid with parallel and other velocity vectors. And also turbulent flow has undesirable properties, in the sense that whenever there is some external disturbance in the flow of fluid, it is going to change all your parameters, all your properties, etc. Next important parameter was viscosity. So viscosity, as I told you, it is the resistance to the motion of a fluid. Whenever the fluid is moving along a well-defined path, or along any path for that sake, and whenever there is a resistance in the motion of that fluid, it is called as the viscosity. So viscosity is a very important parameter. Next important parameter is called as Reynolds number. So it is a very dimensionless number. So you know that there are certain parameters in physics and fluid mechanics which are dimensionless numbers, which is not having any dimensions. So those dimensionless numbers, out of which one number is called as Reynolds number, which plays an important role here. So a dimensionless number, Reynolds number, is used in fluid mechanics to indicate whether the fluid will have a steady flow, or a laminar flow, or a turbulent flow, what kind of flow it is, what kind of flow the fluid is moving. So that will be determined by the Reynolds number. The formula for calculating the Reynolds number will be RE. RE is the symbol for Reynolds number. RE will be equal to rho Vd upon mu, where rho stands for density, V stands for velocity, D stands for diameter, divided by mu. Mu stands for absolute viscosity. Okay, so now coming to the types of drag. So first drag, which is generally the types of drag are generally determined using the following categories. So one is called as parasitic drag. Parasitic drag. It is, in other words, it is called as viscous drag. The other drag is pressure drag. Pressure drag is also called as form drag. FORM, form drag. We also have skin friction drag. So the parasitic drag is further subdivided into two, that is pressure drag and form drag. The second classification is induced drag, and the third classification is compressibility drag. So you have got to remember these three kinds of drag: parasitic drag, among which we also have two subdivisions, that is pressure drag and form drag, and second is induced drag, third one is compressibility drag. So you have to remember these three drag types. Now going on to the pressure drag or parasitic drag, first point, or before going to the pressure drag, let me tell you about the parasitic drag. Parasitic drag will act on an object when the object is moving through a fluid. Definitely, the drag is something that will definitely act whenever the object is moving through a fluid. And it is made up of multiple components, including the viscous pressure drag and skin friction drag. So in viscous friction drag, it will occur only when the pressure between fore and aft surfaces do not balance at all. But skin friction drag, it is the drag due to the surface roughness. Due to the surface roughness, the skin friction drag will come into the picture. So pressure drag, most of the drag experienced by holding your hand perpendicular to the ground outside a vehicle window to the airstream is pressure drag. And pressure drag results from the difference in pressure between the fore and sides of the hand. So next one is skin friction drag. So it is a kind of frictional force over a surface. So frictional force over any surface is called as skin friction drag or viscous drag. For an example, the example is flat plate parallel to the airflow that will experience skin friction drag. Okay, so frictional force over a surface is called as skin friction drag, and also the skin friction drag will occur due to the surface roughness. So only when there is a rough surface, the friction is going to come into picture, and then the frictional force over that surface will be called as the skin friction drag. And the best example is flat plate parallel to the airflow that will experience a skin friction drag. So next is the parasitic drag. I already told you an object will have friction along the surface and some pressure drag because a wake is being formed behind it. Pressure drag and skin friction drag are not entirely independent because the size of the wake is dependent on the point of separation of flow. So that's all about the parasitic drag. Next, we come across one of the important parameter which is called as drag coefficient. So drag coefficient, in the previous class also I have briefed you about the term which is called as CD. CD is nothing but the drag coefficient. Since it's a coefficient, it is a dimensionless quantity. So it is a measure of the effectiveness of a streamlined aerodynamic body shape in how well it is good in reducing the air resistance to the forward motion of the vehicle. So it is a term which is used to quantify the drag, how much drag force has appeared. So it is a term that will quantify that drag. So drag or resistance of an object in fluid environment, and by fluid I mean to say air or water. So it is also used in the drag equation. So we'll have a look at the drag equation. CD is very important parameter in the drag equation, in which a lower drag coefficient indicates the object will have less aerodynamic or hydrodynamic drag. So less the hydrodynamic drag means the CD value will be very less. That is, the drag coefficient will be very less. And the drag coefficient is always associated with a particular surface area. Yes, the coefficient is always dependent upon the area. And here in the tabular column, you can easily see I have listed the type of vehicle and the drag coefficient associated with it. If you have a saloon car, the drag coefficient generally which comes is 0.22 to 0.4. Generally, the drag coefficient or the CD will be less than 1. For sports car, it is roughly 0.28 to 0.4. For light van, it is 0.35 to 0.5. For buses and coaches, it is 0.4 to 0.8. For articulated trucks, it is 0.55 to 0.8. For rigid truck and drawbar trailer, it is 0.7 to 0.9. So drag coefficient varies because it is always associated with a particular surface area, and the surface area of all these kinds of vehicles are different, and hence Hence, the drag coefficient is also different. And the drag coefficient, the main purpose, it is to quantify the drag or resistance of an object in a fluid environment such as air or water. So next is form drag or profile drag. So form drag, as you can see in the image also, I have shown you an image where the form drag is acting. So form drag is directly affected by basic shape of the vehicle body as created by the body engineer. So the form drag has, as the name suggests, form. Form means shape. So it is directly affected by the shape of the vehicular body as created by the body engineer. So next kind of drag, that is called as induced drag or the lift drag. So streamlined body and blunt body, as I've already told you, for streamlined body there will be a small form drag, whereas for a blunt body, as you can see in this diagram, you will have a large form drag. Next is induced or lift drag. So induced or lift drag means, induced or lift drag is the result of any lift force that is generated by the moving vehicle. And the magnitude of the lift force is primarily a function of the basic body shape. So a lift drag is an aerodynamic drag force that occurs whenever a moving object redirects the airflow coming at it. It will redirect the airflow coming to it. And this drag force occurs in cars with airfoil wings that redirect the air to cause a down force. So okay, so here you can see in the diagram that the diagram is having lift and down force from over body flow. In the lift drag, it, as I told you, that is the force that occurs whenever a moving object redirects the airflow coming to it. So next one is called as surface or frictional drag. So surface drag is a frictional resistance that results from air passing tangentially. The velocity of air produced a thin layer called the boundary layer next, which slows the velocity of air due to tangential frictional forces. So next one is called as interference drag. So in interference drag, you can see the interference drag. I have shown you the image of so in surface drag, smooth surface means small friction, rough surface means large friction. But in interference drag, you can see the image of a car, and I have also marked the where the interference drag is there. So interference drag is caused by the projection and protuberance that exist on the basic body, the exterior vehicle body projections such as hood ornament, windshield wipers, radio aerial, rear view mirror, air scoop, roof pillars, etc. etc. All these parameters contributes to the total interference drag. So next is internal flow or cooling and ventilation drag. So you can see in the diagram, it shows the image of a car where the internal flow drag or the cooling drag or the ventilation drag, it is the sum of all energy losses produced when the air will pass into, through or out of all vehicle system, requiring or permitting the airflow from whichever point the air is entering or exiting from the vehicle body. So there will be energy loss. So that sum of all the energy loss produced whenever the air is moving into or moving through the vehicle or moving out of the vehicle, so that is called as internal flow drag. The engine cooling flow, which is primary internal flow component plus passenger ventilation flow and any internal flow required to cool the brakes, mechanical components, that contributes to the internal flow drag. And internal flow drag is generally it is about 12% of the total drag. So total drag, as I told you, there are various kinds of drag, among which 12% is contributed by the internal flow drag or cooling and ventilation drag. So as we come to the end of the drag, the other objective which I mentioned in the first few slides was all about wind tunnels. So wind tunnels is the next topic, and wind tunnels are used to simulate the airflow in laboratories under the controlled conditions. So in the subsequent slides, you will see the images of the wind tunnel where you'll be able to understand that they are there are certain design which are used to simulate the airflow in laboratories under controlled conditions. So they find vast application in automobile and aircraft industry to test the prototype for aerodynamic conditions, specifically the drag force on the prototype. So in order to study the amount of drag force that exists on the object, so we will make use of the instrument which is called as the wind tunnel. So school laboratories utilize them to study the flow around small objects like a sphere or a wedge. So whenever in our younger days, we had something called as a sphere and wedge, and the air will move around it, and we will study how the air flow around small objects like sphere or a wedge. So in school laboratories, we would have done that. So wind tunnels are designed for specific purposes. So wind tunnel design for school lab is generally between 2 meter to 12 meter long, while the wind tunnel for automobile purpose, they are very large to accommodate the whole car in its test section. So these days, wind tunnels are being replaced by CFD tools. CFD stands for Computational Fluid Dynamics tools. This is one of the important software through which you can design any fluid dynamic component. So these days, the wind tunnels are being replaced by the CFD tools. So next, coming to the types of wind tunnel. So we have wind tunnels being classified based on airflow speed in test section and based on shape. So first one is based on flow speed. We have subsonic or low speed wind tunnels, transonic wind tunnels, supersonic wind tunnels, hypersonic wind tunnels. These four classifications are based on flow speed. And we also have four more wind tunnel based on shape, that is open circuit wind tunnel, sub down tunnel, blower tunnel, and closed circuit wind tunnel. So as you know that wind tunnels are classified based on shape and also based on the speed. So in the first category, this slide will tell you about the subsonic or low speed wind tunnels. So as you can see in the image, that this kind of low speed wind tunnels are also available in the laboratories of universities, where we have this kind of setup in our fluid mechanics lab as well. So the maximum flow speed in this type of wind tunnel can be 135 meter per second. Whenever the flow speed of the air is around 135 meter per second, we have to restrict our wind tunnel. So flow speed in wind tunnel is generally preferred in terms of Mach number, so which comes out to be around 0.4 for this case. So Mach number is another dimensionless parameter like Reynolds number. So here the Mach number should be around 0.4 when it comes to subsonic or low speed wind tunnel. And this type of wind tunnels is most cost effective due to the simplicity of the design and low wind speed. And generally the low speed wind tunnels are found in schools and universities and at a very low budget also. So this is all about the subsonic or low speed wind tunnels. So in the transonic wind tunnels, which is the second type of wind tunnel, you can see the diagrammatic view where the maximum velocity in test section can reach up to speed of sound, and you know the speed of sound is 340 meter per second, whereas in the previous wind tunnel it was only 135 meter per second, but here it is 340 meter per second, and it can reach up to a Mach number of 1. And these wind tunnels are very common in aircraft industry, as most aircrafts operate around this speed. So here you can see the image also, the transonic wind tunnels, they are operating at speed of sound. So next is supersonic wind tunnels. As the name suggests, it is supersonic, that is velocity of air in test section of such wind tunnels can reach up to Mach of 5, that is 1715 meter per second. And this is accomplished using convergent divergent nozzles. The power requirement for such wind tunnels is very high. So next is hypersonic wind tunnels. The wind velocity in test section of such type of wind tunnel can measure between Mach number 5 and Mach number 15, and it is having a speed of 18,522 km per hour, and this is also achieved by using convergent divergent nozzles. So in summary, I can conclude by saying that the drag coefficient is a very common measure in automotive design as it pertains to aerodynamics, and drag is a force that will act parallel to and the same direction as the airflow. The drag coefficient of an automobile measures the way the automobile passes through the surrounding air, and for different vehicle the drag coefficient is different, and it depends upon the surface area that it touches also. These are few of the reference from where you can have a more insight on these topics. So these are few of the questions for practice. First question is, what is the effect of lift and drag forces on the aerodynamic stability of a body? Second, list the importance of CD and mention the CDs of various engines. CD means coefficient of discharge. So what steps can be carried to reduce the air resistance of a moving object? Fourth, what are the different types of drag with examples? Fifth, explain the role of lift and drag force in aircraft movement. Thank you.